Traditionally, performing rectal ESD on folds or valves is challenging. ESD against colorectal neoplasm on the folds is technically difficult. Perforation risk and en bloc resection failure risk. Novel device to overcome such problems through add-on devices are scarce in the literature. So novel device to overcome such problems. The conventional way of performing endoscopic submucosal dissection uses caps on the endoscope chip. This aims to provide traction, separating the camera from the tissue. To overcome some of the limitations of this technique, we designed and developed a double balloon device with independent inflation control and variable distance functions. The after balloon is fixed in position behind the endoscope chip, whereas the fore balloon can be extended in front of the endoscope chip, providing tissue traction. The advantages of using this device compared to the traditional ESD method is the ability to stabilize the endoscope chip within the lumen, as well as providing tissue retraction to aid dissection. The retraction is archived by attaching the free mucosal edge to the fore balloon through clip application. For this experiment, we created a novel 3D model of the abdominal pelvic region into which we placed ex vivo fresh porcine intestine. This provided a more realistic model. We simulated the rectal folds by imbricating rectal serosa. You can see here on the right-hand side the screen the accuracy of the simulation through the endoscope view. Region size was 3.5 centimeter in diameter, located 13 centimeter from the anus on the superior rectal valve. In addition to the standard equipment, we used the short version of the double balloon system, which is 103 centimeter long and ideally suited for rectal procedures. Here, we show the traditional cap methods for performing the traditional rectal ESD. You can clearly see the rectal fold simulation. After the region borders have been incised, submucosal dissection commences. We performed dissection on the injected areas immediately as to utilize the lift which dissipates over time. Here you can see how difficult it is to provide retraction over the fold, leading to inefficient dissection of the region. Here, we see the double balloon traction technique. Extending the fore balloon past the rectal fold region. After the fore balloon is inflated, submucosal injection commences. Once submucosal injection has been performed, the balloon is orientated, circumferential mucosal incision is undertaken. After the mucosal edge has been formed, the edge is clipped to the fore balloon. This provides a retraction, as you can see here. In this system, the endoscope can be moved within the oversheath. With this flexible position, dissection proceeds with ease. As you can see here, the dissection over the fold proceeds efficiently. Here, you can clearly see the muscle layers and submucosal layers. And as the endoscope can rotate within the sheath, different orientation dissection can be performed with ease. The retraction can be consistently adjusted to allow dissection to proceed efficiently. Here, we see the specimen post-procedure showing no perforation and clear margins. In summary, we were able to perform the complex rectal ESD on the fold using the double balloon technique with retraction. The technique resulted in a more efficient dissection, providing increased stability and feasibility. Here are our limitations. In conclusion, we feel double balloon-assisted rectal ESD is technically feasible. It added features to the flexible endoscope system due to its short length, improved stability, and the ability to provide traction. Further experimentation is ongoing, and a human registry study is currently in place. We are also pleased to report that since the submission of this abstract to SAGES, we have performed this technique in humans with success. Thank you for attention.